All right, so today we're working on factoring quadratic expressions and specifically simple trinomials or simple quadratic expressions. All right, and how do you know if you're dealing with a simple trinomial or a simple quadratic expression? Well, that's when the a value, when written in standard form, has a value of 1. All right, so when the coefficient, the a value or the coefficient of the x squared term is always 1. All right, and you can see in these examples written right below, here's a 1 and here 1. So these are both simple trinomials. Or quadratic expressions. And the word trinomial is because there's 3 terms. So the first thing we're going to do is I want you to notice any pattern moving from factored form to expanded form. And again, to go from one to the other, you would expand factored to get into expanded form. And that method is foiling, as we covered in the previous lesson. So pause here, and I want you to see if you can see any patterns with these numbers here and these numbers here. And technically there's a number in front of these x as well. All right, so if you did pause and you did try for yourself, you would see that when you take this 7, or these numbers right here in the back, right, the 7 and the 3, when added together, they give you this middle term right here. And then when you multiply them, 7 and 3, they give you this backside term right here. And that pattern holds true for every single one. 4 and 5, when added together, will give you the 9, and 4 times 5 will give you this 20. 6 minus 2, well, that gives you positive 4. 6 times negative 2, keep in mind the negative on the 2, and that's how you get this negative 12 right here. Well, you also have 3, when added to 10, gives you 7. And then when 3 times 10, you get minus 30. And notice how there's always a 1. All of these have a 1, 1, 1, 1. That's because the numbers that are in front of those variables, those inside the bracket here, are always 1. So in the case, they're always 1 in the simple trinomial. So the observation, all right, well, we see that the numbers in the brackets, when added, equal the b term. And the b term in a expression like this is that middle term. There's your b term. These are the b terms right here. And then when those same numbers, when the numbers are multiplied, they equal they equal the C value, or the C term, I should say. C term. All right. So let's use these observations, all right, same observation, to answer this next part right here. Well, in this case, we're starting with expanded form, all right, and we're going to factored form. So we're going this way right here, all right? So going from expanded to factored, you have to factor. Well, using those observations we said above, all right, well, notice here we have our b term. Our b term here is positive 2. Well, the numbers that you see here and here, they have to add together to give you 2. If one of them is already 1, that means this has to be positive 1, because 1 plus 1 gives you that 2. And then does it satisfy the last part, where we have a value of plus 1? Yes, 1 times 1 gives you that plus 1. Okay, so try it out. All All right, you can pause here and try out, see if you can fill it out yourself. Otherwise, I'm going to keep going. So you see that we have a 3 here in the middle, and we have a 2 here in the back. So whatever numbers go right here and here need to satisfy multiplying, in this case, they have to multiply to give you 2, and they have to add up to give you 3. So what combination, if one of the numbers is already given to me as 1, well, that means this has to be, the other number has to be 2. 2. And that's the process that we go about doing each one of these, okay? Well, in this case, we're going the opposite direction, all right? Well, my unknown is the middle, is the b value here. So that b value comes from taking this and adding it to this. So that would be 5. Once again, we have an unknown b value, but we also have an unknown number here. Well, the thing that has been specified for us is this c value right here. And that c value comes from taking two numbers and multiplying them. And that would have to equal 5. Well, I've specified one of the numbers already. Here, it's 5. So the only other possibility is this would have to then be 1. This would have to be 1. Well, that means this right here, this b value is when you take that 1 and you add that 5. So that would be 6. Okay? So we have more practice using this sort of chart, this table I've decorated here, right? It's just a way to organize and find what these numbers are. So key thing, we are factoring, right? So this right here is standard form. And remember, to get to the different form, being factored form, we need to factor. And just as a recap from yesterday, or maybe not yesterday, but previous lesson, to go the other direction, it's expanding, right? Okay, so we are given this trinomial here, this simple trinomial. Well, using the observation, the pattern that we've recognized, we need two numbers that when multiplied together, give us 36. Well, the same two numbers would have to then be added to give us 15 here. So what is the thought process here? Well, you have to start by looking at what are the multiples of 36. So 36 has multiples of 1 and 36, and you just keep doing this until you get to a part where one of the multiples, if you were to either add or subtract here, would give you a value of 15. So just keep going with them. So the next one we have 3 and 12, and we're going to stop there. Because if I was to add here, I would get 15, right? 3 plus 12 gives you 15, the B term. So that means your two numbers, and these have to be the same numbers, right? You can't put different numbers for the top and the bottom. Once you've determined those numbers, it's pretty straightforward at this point. Well, that means x squared plus 15x plus 36, when you factor it, well, in this case, x is our variable, and it's only a 1 in front here. So this has a 1, and then this one would also have technically a 1. And then you just found that the numbers that go on the backside are 3 and 12. And there you go. That is in factored form, and you don't need these ones here. So x plus 3 and x plus 12. So we're going to have some more practice doing that, right? Just you're setting up this table right here. And you just need to really know your multiples. So looking at this one, all right, here's your B, here's your C. So set up your chart for your table. You need two numbers that multiply to give you that positive 20, and keep in track with the sign, okay? So it is positive 20 and positive 9. Those same two numbers have to add up to give you 9. So go through and think, what are my multiples of 20? And you just keep writing the combinations out until you get to stop at one that if you were to either add or subtract, would give you 9. So in this case, 4 plus 5. So that means this is 4 and 5 when multiplied would give you 20. And when 4 and 5 are added together, they give you 9. So when we factor this, because again, this is simple, it will all, when you ever see a value being here 1, it's whatever variable you see here, you just write it, and then you add the things you just found. X plus 5. And there you go. There's factored form. So here we have our backside being 6 and 7, and the middle side being 7. So when we multiply them together, it has to give you 6. And when these are added together, they have to give you 7. So what are the multiples of 6? All right, so 6 is 1 and 6, 2 and 3. And actually, I could have stopped at the beginning because 1 plus 6 would give me 7. So this would have to be 1 and 6. 1 and 6. So your simple trinomial factoring is just x plus 1, x plus 6. There's factored form. And you can always check this by foiling. All right? And so checking that would be, well, x plus 1, x plus 6. Remember, foiling, that we did in the previous lesson, is taking the first times the first. So that would give us x squared. First times the outside. So the O part of foiling. So plus 6x. 1 times this x plus x. And then 1 times that 6 plus 6. Collect your like terms. And notice how you get the same thing that we started with. So this is in fact factored form. We expand it out to get to check. All right. So this one just looks a little more complicated because we have these negatives here. And that's why I said keep track of your signs, all right? So in reality here, in this problem, which makes this one more difficult, is we need two numbers that when multiplied together give us minus 40, not positive 40, minus 40. And then those same two numbers when added together would have to give you minus 3. All right, so what you want to do is go same process then at this point. So you go, okay, well, what are my multiples of 40? And before we keep going on, I want you to do a logic check and say, well, how do I get this negative here when I'm multiplying? Well, that negative can only come if one of the numbers here is positive and one of them is negative. Because if this number right here was positive, for example, this would result in a positive number. If these both numbers were negative, once again, that would result in a positive. So the only combination is one of the numbers has to be positive and one of them has to be negative. So that same positive would have to go here, and that same negative will have to go here. So when you're writing out your list of 40s, keep in mind that when you go and you're listing them out, you have to think, okay, well, what happens if I make this one negative or positive? What happens if I make this one negative or positive? When you kind of have to do a little mental math, and you say, well, would any one of those combinations give me minus 3? No, not the case here, right? So then you keep going, writing out your multiples until you can kind of get to 1 where you would get a combination that would give you minus 3. So then 2 and 20, nope. All right, 4 and 10, nope. We have 5 and 9. Not 5 and 9, sorry. 5 and 8. It's 40, not 45. And yes, there we go. That would be the one to stop. Because notice that if I make, and this is a negative here, so I'm going to put the negative on the bigger number. So if I make this negative 8 and this positive, when I add or subtract those numbers, I will get minus 3. So that means this needs to be negative 8, and this needs to be 5. 5, negative 8. And there you go. just fill in your brackets. So we have x plus 5, x minus 8 equals. Make sure you remember equal signs. That's factored form. All right, next one. Well, this time we're not dealing with x's, we're dealing with n's. So we know that it'll just be n here, and then the process is the same otherwise. Find two numbers that when multiplied give you the last term, so 36 in this case. And those same two numbers when added would have to give you 20. So go through your multiples of 36. So 36's multiples are 1, 36, 2, 18, and I'm going to stop there because plus 2 and plus 18 give me 20. So that means this is 18, 2, and it doesn't matter what order you put these in. 18, 2, so plus 18, plus 2. There we go. So now try both common factoring first, then factoring the remaining binomial. So notice how at first glance here, you're not dealing with simple trinomials because here the a is 2, here the a is 6, here the a is 4, and here the a is 7. And remember, for it to be simple, a has to be 1. So this is where the common factoring comes first, okay? So looking at this, well, I know that I can factor out this 2 from this 22 and this 56 because they're all common, they're all even, sorry. So if I factor that out, that would become 2, right? I factor it out, so you write it on the outside of the brackets, x squared. And then what is 22 divided by 2? Well, you get plus 11x. 56 divided by 2 would be plus 28. All right, and now if we look at just this inside part right here, this part right here, let's factor that. So nothing happens with that 2. The 2 is still coming along because you can't get rid of it. It's just factored out. But now we're just going to factor that thing underlined in purple. So we need two numbers that when multiplied give us 28. And those same two numbers have to add up to give us 11. Go through your multiples of 28 and you would find it would be 7 and 4. 7 and 4. So that means your answer, that 2, like I said, is still in front. And now it is a simple trinomial because there's a 1 here in front of the x. So that means you just put an x here. And then you have plus 7. And then you have x plus 4. There you go. All right, so it's just simple factoring with this addition of common factoring at the beginning. So go over here, right? In this case, I can turn this a into a 1 if I get rid of this 6 right here. That's the goal. So ask yourself, well, can I get rid of it? Like, can I factor it out from each of these terms? And yes, because each one of those can be divided by 6. So if we factor out the 6 from each term, okay, you'd be left with x squared plus 4x minus 5. Now we look at factoring this right here using the method. So find two numbers when multiplied, and in this case, keep in mind it is minus 5 that goes on the backside here. So that means one of these is going to have to be positive and one of them is going to have to be negative when we go through our multiples. And then those same two numbers have to add up to give us 4. Right? And again, one of these has to be positive and one of them will have to be negative. So what combination of numbers multiply to 5? Well, because 5 is prime, there's only one combination. So that means this would have to be 5 and 1. And how did I know it was not the other way around where it was plus 1 and minus 5? That's because if I put these same numbers here, this is a positive number. But if I made it minus 5, it would result in this being a negative number. So the sign has to go to the bigger one. So because this is positive, the bigger number gets the positive. And there we go. Just write it out because, again, this is a value of 1 now. It is a simple trinomial, so it's x plus 5, x minus 1. And that is factored form. So let's go through the next one. We need to get rid of this. Getting rid of it means factoring it out. So ask yourself, can I factor from all of these? And yes, 4 can go into each one of those. That means it is factorable. So pull out the 4 from each term. And when you're pulling it out, that means dividing every term by 4. So 4x squared divided by 4 is x squared. Plus 4x divided by 4, x. Minus 8 divided by 4, minus 2. And if you were to expand this 4 back in, you would get exactly what you started with. So you know you did it correctly. Alrighty. So we need now 2 numbers, because we're going to factor this right here, the simple one. We need 2 numbers that when multiplied give us minus 2. Again, you're dealing with a negative. Plus, they have to add 2. And there is technically a plus 1 here, okay? So it is plus 1. So what are the multiples of 2? And again, this is a negative here. So that means one of these has to be positive. One of them has to be negative. All right, and 2's multiples are only 2 and negative 1, 2 and 1, sorry. And because this is positive 1, I know that if I'm deciding which do I put the 2 or the 1 here, well, that is correct because 2 is bigger than 1, and this is a positive, so that means it has to be positive 2 plus negative 1. And there you go. So this would be 4x plus 2 x minus 1. All right, last one. So get rid of that 7, check. Can I divide this by 7, this by 7? Yes. Even though it's a bigger number, yes, you can. But it's okay, pull out your calculator. So this would be 7b squared. 28b divided by 7 would give you 4b. 147 divided by 7 would give you 21, negative 21. Okay, factor this. So once again, because it's b in front here, and it has a value of 1, we know we're just going to get 7. And you'll have the b in front by itself because it's now simple. But we need to figure out what numbers to put in the brackets. So 2 numbers that multiply to give you minus 21. 2 numbers that add up to give you 4. All right, so go through if you're not familiar with your multiples of 21. And again, this is negative. So we'll have a positive and a negative combination. All right. Well, multiples of 21 are 1 and 21. And you're going to stop when you get one that would give you 4. And then you have 3 and 7. And there we go. Because if I want to make this positive 4, I know that if I make this negative 3 and this plus 7, that would give you positive 4. So it's 7 and minus 3. 7 and minus 3. So 7 and minus 3. Almost done. So determine binomials that represent the dimensions of the rectangular Warden garden shown below. Alrighty. So this looks complicated at first glance, but honestly it's really not. The key thing is, again, that this is a rectangular water garden, okay? So if I'm giving you an expression for area, remember area is the combination, or is length, area of a rectangle is length times width. So what I want to do is I want to factor this simple trinomial. If I know that my area is this expression, x squared plus 5x plus 6, well then, if I factor this, if I go through and I factor it, and I get my two brackets, notice how this would be, one bracket would represent length, and the other bracket would represent width. It's like two things multiplied by each other, so find your factors. So if we factor this trinomial here, we need two numbers that multiply to 6, and those same two numbers have to add to 5. So go through your multiples of 6, and you would find that the combination that works is 2 and 3. 2 and 3. So you would have simple trinomial again. So you just write x, and then it'd be plus 2. And this would be x plus 3. And there you go. So this one right here, doesn't matter which one you call which, but let's call this one length. Let's call this bracket width, right? If you take x plus 2 and you multiply it by x plus 3, I'll show you. I called it the other way around, so sorry. I called this one width, x plus 3. And I called this one length, x plus 2. If you take this length and this width and you multiply them together, so if you take this length, x plus 2, and you take this width, x plus 3, what do you get? Well, FOIL it out. So you'd get x squared times that plus 3x, sorry, did it black, plus 3x, 2 times that, plus 2x, and then 2 times this 3, plus 6, you get x, collect your like terms, 5x plus 6. And notice how this is indeed the same area expression. So that means this is the length and this is the width. Last question, what are the dimensions if x represents 1 meter? All right, well, if you have your area expression, if you have your new area expression you created where area is x plus 2 and x plus 3, well, I want to know what does it represent when x equals 1. So take 1 and substitute in for that x and that x. So area is 1 plus 2 and 1 plus 3. So you get area equals 3 times 4 or 12. And in this case, it's meters. So meters squared. It's an application word problem, so please use your units. Alrighty. So please we'll go through the homework in class. All right. If you have any questions on any particular question here that we've covered, just start and we'll take it up as well. All right. Take care.